So we are going through the questions of analog communication. So I think we have discussed the question of 2004, GATE 2004. Okay, so let me share the question first. So yes, we are going to this question. And so in this question, we have already seen the portion up to which, like, as it is given that there is a 1 megahertz signal with 1 volt of the amplitude, and the carrier also. The carrier also has the same amplitude, okay, of 1 volt here also, and the modulating signal also has a 1 volt of the amplitude. So we have assumed that the carrier or the message signal is given as, so let CT, the carrier signal, let it be as cos of 2 pi FCT. So what is the value of FC here? We have the value of FC as 100 megahertz. So it can be written as 100 into 10 to the power 6, 2 pi FCT. Okay. And the value of MT or the message signal is nothing but 1 megahertz, 1 volt signal. So here A cos 2 pi FCT. So what the value of A is given here as 1 volt in case of message signal as well as the carrier signal. So it should be 1 cos of 2 pi FMT. So what is the value of FM here? FM is 1 megahertz, that is 1 into 10 to the power 6 T. Okay. Now here what is given, that here is a balanced modulator. So after balanced modulator,
सर आपका आवाज बहुत ज्यादा कट रहा है और स्क्रीन भी विजिबल नहीं है.
okay, actually today the internet connection or the mobile network is very weak. Because the mobile network is very weak.
Hello, sir.
Yes.
Hello.
Yes.
Yes, sir. Your network is so weak, sir. We are not getting you.
Yes, sir, बहुत ज्यादा कट.
थोड़ा network weak है. So am I audible clearly now?
सर आवाज कट रहा है बीच बीच में.
अभी ठीक है?
Yes, sir.
Okay. So we have seen that the carrier signal. Okay. So according to question in the block diagram, you can see here that here is a signal, one signal, which is MT, the message signal, and here a carrier signal CT. Okay. So the frequencies of the carrier signal and the modulating signal or the message signal is given, frequency as well as the amplitude. So amplitude is 1 volt for both the cases. So we can write CT is equal to 1 cos 2 pi FCT. So value of FC here is 100 megahertz and the value of FM is 1 megahertz. Okay. So as both of these signals are passing through the balanced modulator, so we will have a double sideband suppressed carrier. So let the output of this DSBSC signal as S1T. Okay, so let it be as S1T, output signal of the balanced modulator. So S1T is what? We will get this as the cos of 2 pi FCT, means 100 into 10 to the power 6 T into cos of 2 pi into 10 to the power 6T. Okay, so we have CT into MT. So cos A into cos B के formula में इसे break करेंगे. So we all know that cos A into cos B is equal to what? So let me change the color. So cos A into cos B is equal to, I think all of you know that it is cos A plus B plus cos A minus B. So here we need 2, so we will multiply and divide by 2. So 2 cos A into cos B is equal to, so half will be there. And so am I audible clearly?
Yes, sir.
Okay, so 2 cos A into cos B is equal to cos A plus B into cos A minus plus cos A minus B. So cos A plus B, A plus B करेंगे मतलब, so 2 pi is here. Okay, A plus B करेंगे तो 100 plus 1 होगा into 10 to the power 6t. Okay, A plus B का वैल्यू ये आ गया, प्लस cos A minus B, cos A minus B, A minus B करेंगे तो we will have 2 pi 100 minus 1 10 to the power 60. Okay, so we have this much. Now next what we will have a half of cos 2 pi 101. Okay, so here we will have 101 into 10 to the power 60. Okay, plus cos of 2 pi into 99 into 10 to the power 60. So here we will have two components, as it is a DSBS signal after passing through balance modulator. We will have two components of cos A plus B plus cos A minus B. Okay, so that is upper sideband and the lower sideband. So now actually what we have to get the function of the value of the envelope. So let us again elaborate this. So 101, so this can be written as, so here what we have got that as it is passed through a high pass filter. Okay, and this signal is what, this signal is passing through a high pass filter, and when we will pass this signal through a high pass filter, then we will have this component, the second one component, the first one component only. Okay, so we can write this expression in terms of cos. So here we have the output of high pass filter is equal to half cos of 2 pi into 101 into 10 to the power 6t only. So we will have what, हाई पास फिल्टर से पास करेंगे तो हमें सिर्फ ये सिग्नल मिलेगा, ये कंपोनेंट मिलेगा. नाउ दिस इज एडेड विथ 1100 मेगाहर्ट्ज सिग्नल. ओके, सो अभी यहाँ पर हमें जो मिलेगा आउटपुट ऑफ एडर. ओके, सो आउटपुट ऑफ एडर हमें क्या मिलेगा, हाफ cos of 2 pi into 101 into 10 to the power 6t प्लस ये जो सिग्नल है, ठीक है, ये जो सिग्नल है 100 मेगाहर्ट्ज 1 वोल्ट 90 डिग्री फेज शिफ्टेड. सो यहाँ पर जो सिग्नल मिलेगा इट विल बी ऑफ 90 डिग्री फेज शिफ्टेड ऑफ वट एवर द सिग्नल वी हैव प्रीवियसली. सो वी विल हैव अ सिग्नल साइनोसॉइडल सिग्नल sin 2 pi f. So what is the value of f here, 100 megahertz, so 100 into 10 to the power 6 t. Okay, so we have this signal now. So what we can do here, we have this 101 and this 100 megahertz signal. So here instead of elaborating this function, we are going to elaborate this function. Okay, the first part, that is, so we will have half, it can be written as cos of 2 pi 100 plus 1 into 10 to the power 6t. Okay, और इसे as it is रहने देते हैं. तो what we will have half cos a plus b के फॉर्मूला में से अगर इसे ब्रेक करें, सो a plus b के फॉर्म में. ओके, सो आप लोग ध्यान दीजिएगा, यहाँ पर cos a plus b के फॉर्म में अगर ब्रेक कर रहे हैं, then we will have cos of 2 pi. So cos A plus B is equal to what? Cos A plus B is equal to cos A into cos B minus sin A into sin B. Okay. So cos A means 100 into 10 to the power 60 into cos of cos B. So cos B is what? It is 2 pi into 1 into 10 to the power 6 t cos A into cos B plus sin A into sin B. So sin is what? Sin A means what? It is 2 pi into 100 into 10 to the power 6.
सर माइनस साइन होगा ना?
Yes. So what is the formula? It is cos A plus B. Yes. Cos A plus B. Here it should be minus. Yes.
माइनस साइन ए साइन बी.
Yes. Here it should be minus. Here it should be a minus. So cos A into cos. So cos A plus B is equal to cos A into cos B minus sin A sin B. Yes. So 2 pi into इतना आ गया into sin B. Sin B is what? 1 into sin 2 pi into 1 into 10 to the power 60. Okay. इसके बाद का जो टर्म है वो ऊपर जो हमारे पास टर्म है sin 2 pi into 100 into 10 to the power 60. Okay. So हमें ये पार्ट मिला है अभी. तो अभी आप मुझे यहाँ से एक चीज क्या बता सकते हो कि जो एनवलप वाला पार्ट है वो कौन सा होगा? क्योंकि हमारे पास, अच्छा ये जो लास्ट वाला पार्ट है प्लस साइन वाला पार्ट, उसे मैं यहाँ पर लिखता हूँ. ठीक है. प्लस साइन ऑफ 2 पाई इंटू 100 इंटू 10 टू द पावर 60. ओके. सो हमें ये जो कंपोनेंट मिला अभी, यहाँ पर इस कंपोनेंट में हमें क्या दिख रहा है? क्या देख पा रहे हो यहाँ पर? इस पूरे टर्म में हमें क्या सिग्नल दिख रहा है? हम यहाँ पर देख पा रहे हैं, यहाँ पर ओके लेट मी चेंज द कलर. यहाँ पर हमें क्या दिख रहा है? 100 इंटू 10 टू द पावर 6. मतलब ये कैरियर वाला पार्ट है, क्योंकि कैरियर का जो फ्रीक्वेंसी था 100 मेगाहर्ट्ज था. ओके. और 100 मेगाहर्ट्ज यहाँ पर जो बाद में हम सिग्नल यहाँ पर दे रहे हैं, दैट इज ऑल्सो ऑफ द फ्रीक्वेंसी ऑफ द ऑर्डर ऑफ कैरियर फ्रीक्वेंसी. ओके. सो कैरियर जो हमने यहाँ पे पहले बैलेंस मॉड्यूलेटर में दिया था, उसका जो फ्रीक्वेंसी है वही सेम फ्रीक्वेंसी यहाँ पर एडर वाले पार्ट में भी है. ओके. सो इट हैज द सेम फ्रीक्वेंसी एज द कैरियर. सो here we have the carrier frequency, here we have the modulating signal frequency. Again here we have in this second term, यहाँ पर हमें कैरियर वाला फ्रीक्वेंसी दिख रहा है, और लास्ट में हमें यहाँ पर क्या दिख रहा है? यहाँ पर साइन वाले पार्ट में हमें दिख रहा है ये मॉड्यूलेटिंग सिग्नल वाला पार्ट है. नेक्स्ट सबसे लास्ट वाला जो साइन 2 पाई 100 पाई टी है, तो यहाँ पर भी जो सिग्नल दिख रहा है, दिस इज नथिंग बट अ कैरियर फ्रीक्वेंसी. सो नाउ अभी हमारा मोटो है क्या? मोटो है हमारा, यहाँ पे जो क्वेश्चन आप लोग देख सकते हैं. क्वेश्चन में क्या था? अकॉर्डिंग टू क्वेश्चन we have to find out the envelope of the resultant signal. You can see in the last line here it is written that the envelope of the resultant signal. Envelope of resultant signal क्या आएगा? तो envelope अगर निकालना है तो हमें we are interested with only the modulating part. Okay, we are interested only about the modulating part. So what we can do here, that let this portion, so we have to find out the resultant. So resultant should be what? Resultant means the envelope. So envelope will be of the magnitude part. So whatever be the magnitude of different terms, a square plus b square plus c square, where a, b, c are the amplitudes of or the values of the signal. So what are the values we have here? So let us see that. So we have the first term as this one. Okay. And the second term we have only this one. So इसके अलावा हमारे पास मॉड्यूलेटिंग फ्रीक्वेंसी वाला और कोई पार्ट है नहीं. ओके. So let us put the values of a and b. So let this be as a and let this be as b. So putting the values of this a and b, let us see what will happen. So I am writing it here. The envelope or the resultant envelope is equal to root under a square plus b square. So the value of a square is half. So half square, क्योंकि यहाँ पर ब्रैकेट के बाहर आप देख रहे हैं यहाँ पर हाफ है. So हाफ स्क्वायर मतलब इससे अगर करें तो 1/4 हो जाएगा. और क्या है cos स्क्वायर 2 पाई into 10 to the power 60, okay, plus इसका स्क्वायर करेंगे. अगर नेगेटिव का भी स्क्वायर करेंगे तो वी विल हैव अ पॉजिटिव वैल्यू. सो यहाँ पर भी हाफ का स्क्वायर होगा और we will have the value as what sine square. So we will have sine square 2 pi into 10 to the power 60, 2 pi into 10 2 pi into 10 to the power 60 यहाँ भी है और 2 pi into 10 to the power 60 यहाँ पर भी है. ठीक है. So what we can get here, यहाँ पर अगर देखें तो what we will have, we have the value of sine 2 pi 100 into 10 to the power 60 and sine 2 pi into 10 to the power 60. So what will happen here? So now we will break the signal as the given value. Okay. So we can write it as the value of the signal. Okay. So we can write it as what? We can write it as half of cos square 2 pi into 10 to the power 60 plus half square sine square 2 pi into 10 to the power 60. Isn't it? Hello? Am I audible?